Hello and welcome to another episode of this Unreal city building tutorial where today I'm actually going to start adding in the population. So as you can see here, I've got just a bunch of people here. When I hit play in my simulation, you'll see this nice long line of people that I've come in, and hopefully when I run you'll eventually start to see these people. They both produce children. You just saw two pop up there, and eventually the parents will die off as well. So that's the aim of this episode, is to get you to this point also, so we can actually start doing some cool stuff with our city, start having people building homes and starting jobs. You can see some people are disappearing because they've now passed on. If you enjoy the video, please subscribe and drop any comments you have below. It gets quite complex at times, so try and take it slow. Pause the video, rewind it, and just follow it at your own speed. Yeah, I hope you enjoy it, and let's get into it. Okay, so next thing I'm going to do is I'm going to create a kind of a manager, another manager class, just an actor, and this is going to be our city builder population manager. I'm going to drag and drop one into world already, just because we don't want to forget to have a manager in the world. And what this is going to do is just kind of control how the population ages, and do stuff like assigning partners together and making kind of a dating pool and stuff like that, spawning new children, all that kind of stuff. So we do have something that controls all our citizens. So the first thing it's going to need is a list of all the citizens, really. All citizens. So this is literally just going to hold an object reference to, which is going to be an array of every single citizen in the game. So all citizens should be created through this population manager, die through this population manager, and all be part of this list, so we always have a link to all of our citizens. So what we need to do is, in the begin play, we need to find all, or is it get all actors of type, of class, sorry. CB citizen, and then set list of all citizens to the out actors of that. So to begin with, we already have a list of all our citizens, and they're already in here, and that's good. That's what we need. We don't need the actor overlap. The way I want my citizens to go through life is on each birthday there will be a chance of something happening. So that's going to be a chance of them either finding a partner, having a child, or dying. So I want to do that on each birthday of the citizen as they get older. So that's kind of what I'm going to do in here. So in this event tick, I'm actually going to create a timer. So I'm going to call this the birthday timer. It's just going to be a float. And then it doesn't want to be an array, it just wants to be a single. In the actual game, I'll probably say that every day, in-game day, is a birthday, but I'm actually just going to say for us that every 1 hour is going to be a birthday. And I'm going to do this based off our time manager. So you might remember a few episodes ago I made this time manager. Kind of controls how fast the simulation is running. So I am actually going to add just a little helper function. And it's just going to be called get current time modifier. This is just going to return a float based on how fast our simulation is running. So it can just be accessed from other areas of the game. The time mode enum, if we get that, and then if we do a switch case on it, plug that in. We want a couple of return nodes, and then we just want to, so if we're currently in the normal speed, then return the normal speed. If we're currently in the fast speed, then return the fast speed. If we're currently in the super fast speed, then return the super fast speed modifier. just so other areas of our game actually know how to adjust the simulations that they're running. So bearing that in mind, let's go back to the population manager. So the birthday timer, and we're going to create a separate variable called the birthday timer max, actually, and this is actually what we'll set to be just 1, like that. The birthday timer will just keep track of everything. So every time the birthday timer gets to 0, we'll update the birthdays. So just to make sure that's all right, in the begin play, set the birthday timer to equal the birthday timer max, like that. The birthday timer max as well, you should probably clamp so that it can never go less than 0, and default it to 1. So on the event tick, what we're going to do is we're going to get actor of class. We're going to find our time manager, CB time manager. We're going to get the current time modifier, so that's a function that we literally just made, and we're going to multiply the delta time by the return value, like that. So based on this, we're going to subtract that from the birthday timer. So get the birthday timer, subtract the thing, and then we're going to set the birthday timer to be this new float, like that. And then this is where we just do the check. So if after this logic the birthday timer is now less than or equal to 0, so less than equal to 0, we know that we want to update all the birthdays. So let's do a branch there, and then the first thing you want to do before you forget is if this comes in as true, then you want to do another set on the birthday timer, and you want to set it back to be the birthday timer max, like that. Hopefully that makes some kind of sense. If I'm going too quickly, please just drop a comment below, and I'll do my best to help you out with that. So now I want to create another function on our actual citizen that will be on a birthday, and it'll update a bunch of stuff, and we'll see what happens. So let's go back to our citizen, add in another function, and we'll call this one on birthday. So the first thing that's going to happen on the birthday is we're going to get the age, we're going to add 1 to it. In fact, we could probably just call the increment int. And then we're going to set the age to be the new one. Okay. So we've got that. Now what else do we need to do on a birthday? So I think that we need to increment the age. We need to check if this person has now died because they've gotten too old or they're too sick. And we also need to add them to a dating pool if we need to, based on a bit of random chance. If this person is in a couple, then we should probably do a check to see if they've generated any children on this birthday. I think the generating children we should actually do from the population manager and not within the citizen. In here, let's just keep it to a death check for now. So to decide whether someone's dead or not, first of all, I'm going to say I don't want to be too morbid in my game. So I'm going to say if the age is currently less than or equal to 20, then they're not going to die. Then they're fine, and we can just return out. We don't need to do any more. However, if they are greater than 20, then there is a possibility that this person might die. So to figure that out, I'm going to just put in a little algorithm here. So I'm going to generate a number create an integer, and it's going to be between 0 and 1,000. So they've got a 1 in 1,000 chance of dying every birthday. But I'm going to scale this based on some factors like their health status and their age. So I'm going to add a local variable in here, and I'm going to call this the health modifier. And it's going to be a float. What this will be in the future, once we actually do some more stuff to the health system, is this will also take into account how good the coverage is around this citizen's area in the world. So this will change in the future as well. But for now, we're just going to do this based off of age and the health status of this person. So I'm going to do a switch statement. I'm actually going to get the variable for the health status. And I'm just going to do a switch on that. And then based on this, I'm going to set the local variable to be a certain integer. So if this person is normal, then the health modifier is just going to be 1. If this person is sick, then there's a 2 times greater chance they're going to die. If this person is dying, so they're severely sick, then this is going to be 20. Like, this person can still recover if they get to a hospital and get cured in time, but the chances that they will perish are significantly higher. So that's the first thing I want to do. So we've got a health modifier, and then we've got this random integer. I'm just going to pull that out there. And then the other thing I wanted to do was I just wanted to get the age. And then the other thing this is based on is age. So if I just pull down the age, and this is going to be a bit of inverse logic. So we know that the age is between 0 and 100. So I'm going to do a division on this. So divide that by 100. Actually, that's going to be, we actually want to cast this to a float first, and then divide it by 100, so we can get some floating point stuff. And then what I'm going to do is I'm going to square this. So this is going to give me a x squared curve on a graph. So the chance of death occurring increases exponentially with age, but starts lower. I'm sure you've all seen the classic x squared curve, but that's basically what I'm getting at with this. So we need to square that. And this will be our modifier. So if I bring all this down here, so I'm just going to do a little comment so we know what this is. So this will be the health modifier based on age, and then from that I'm going to multiply this to the health. So this needs to be multiplied by this health modifier that we've set. So let's get that out, and then we need to do a little equation. So if this random integer between 0 and 1,000 is less than the health modifier that we've generated, then this person will unfortunately die and be marked for death. So the return value, if this is less than, I'll just do a less than to be kind. That's going to be a branch. All these need to go into this branch. Actually, I can just double click on that, and then we can move it all into one location, just for a bit of neatness. So our random integer, is this random integer less than our generated number value? If this is true, then this person now needs to die. And I'll handle death through the population manager, I think. So I think the best thing to do is to have an output on this, which would be is marked for death, which sounds very morbid, but there you go. And then Actually, I could just add a return node in here. And I can just plug this in. So if that value is less than that, then this person is marked for death. If this return node triggers, then false. This person is not marked for death. And there we go. I think that's all we need to do in this for now. I'm sure I'll think of something later and come back to it. But yeah, cool. So back to the population manager. Now we just need to create a function in here, and we're going to just say update all citizens for birthday. And in our event graph, if this condition has been met, then we call the update all citizens for birthday because it's everyone's birthday, which is good. Let's go back into there. And now we're going to get all our citizens and we're going to loop through them. And I'm actually going to do a reverse for each loop, which will become apparent as to why very shortly. Plug that in with the array element. We're going to call our onBirthday function that we've made. Plug that in. And this is the reason I've done a reverse for each loop, because if this citizen is marked for death, then what I want to do is actually delete them out of this list. But if you're doing a loop forward, and you delete this person while you're looping through, you're actually changing the size of this loop, which causes all kinds of errors. So this is why we do this backwards, because if I delete this element that I'm currently on, the loop does get shorter, but because I'm looping backwards, all the elements previous don't actually move, and they all stay there. Whereas if you're going forwards, the entire array would shift by 1, so you'd either skip someone or you would end up going off the bounds of the array at the end, and all kinds of things can occur. So that's why I'm doing a reverse for each loop there. So is this citizen marked for death? So we need to branch that. If this is true, then I guess we need to just destroy the citizen, right? Before we do destroy them, what we probably want to do is, in fact, I'm not sure if I exposed the variable for this. Let's expose the partner and then go back to our population manager. Basically, we want to do get partner, and we want to tell the partner that they're now widowed, essentially. So again, we would need to, in fact, let's just expose all these variables. We want to be able to see them from almost anywhere, right? Back to population manager, and this partner, we now need to do the relationship status. So we need to set this person to widowed, and we also need to get their partner to be a null reference because they no longer have a partner. And we don't want them attached to this partner because we're about to delete this actor. So we don't want that reference there anymore. We want to break it. And then we want to actually remove this from, we want to remove that actor from the list that we're currently looping through. And then we also want to destroy the actor as a final thing. Okay, so if dead. So if this person has come back and they're marked for death, then we tell the partner is now widowed. We actually probably only want to do that if a partner exists. So let's just do an is valid. We can bring this down here. If is valid is there. If not valid, then just jump straight across. Yeah, so is our partner a valid object? Then tell them that we're done and we're no longer the partner. Either way, we need to remove this actor from the list of all citizens and destroy them. Cool. Okay, so that's the birthday deaths done. The second thing that we want to do is we've caused death, now we want to try and cause some life. So once this is completed, we're going to do another for loop on this list. So this time it doesn't matter if we're going forwards or backwards. Got that completed. So what we're going to do now is we're just going to run through everyone who has a partner and give them a random chance to have a child, essentially. So to do that, the first thing we need to do is we need to check their status. So their relationship status. If it is equal to, if they are partnered, let's do a branch. If this person is partnered, then let's give them a chance to have a child. So this is going to be another small little algorithm, I guess. So what I'm going to do is going to use the age as a bit of a gauge for this. So I'm going to say if this person is partnered, I also want to check that this person is... I'm going to say that in our world, you're not going to be able to have children if you're greater than 50. So you need to be... In fact, let's do it. Can we do a range? In range, yes, that's good. So we need to say that this person needs to be at least 20, but as a max can only be 50 to have a child. So let's just make sure that lines up and make sure this is true as well. Once again, we need the age here. So we need to, what I want to do is I'm going to actually do an addition on this. I'm going to add the age of this person to the age of their partner. So if I get their partner and then I get the age of the partner, and then this should, because the min and max is 50, then this should be around about a value, could be anywhere between 40 and 100. I'm going to do an integer subtract here. So I'm going to do 100 minus the sum of the partner's ages here. And then I'm going to multiply this by, let's say I want a random chance of, I'm going to give, on each birthday there's going to be about a 5% chance that you're going to have a child between these ages. But yeah, because we've done this offset, so the older you get, the less likely it is to happen. And then now we can do our random integer with the max being 100. If the return value is less than this number that we've generated, then we're going to spawn children. So that's another branch. Lots of branches, I know it's getting a bit messy. So should have child. Okay, so let's just run through this logic again quickly. So for each person, is this person partnered? Yes. Is this person's age between 20 and 50? Yes. Okay. Has the random chance occurred? Yes. Then we want to generate a child. Okay, so I guess now what we need to do is we need to spawn an actor from class. So we're going to create a child. The class is going to be our CB citizen. Always spawn, ignore collisions. Spawn transform. That's going to be interesting. So let's actually get the world transform of the target of the parent. So if we actually just set that to our parent's transform, and then we're going to set this actor's location based on, we're going to get the actor location. And then we're going to do a vector. Oh. Then we're going to do a vector and a vector. And we're just going to add 200 in the Y. And we're going to plug that in. So we've got it's kind of going to stay in line with the parent there, hopefully. And then the last thing we want to do is we just want to tell the children, the parents, about each other. So our target, we need to bring that down. I'm going to actually just make another quick function in here that will just be add child. It's going to take in a new CB citizen, like that. And this will do our logic for us. So the child will come in, we will get our children of citizen, and we're going to do an add, and we're going to add in the thing that we've passed in. So that's added in. Like that. And then let's go back to population manager, and we're just gonna call on the array element on this, we're gonna say add child, and that's going to be the new thing coming in, and we want to make sure that we do this for the partner as well. So let's do add child and plug that in as well. Hopefully that will work, but we shall certainly see. It's a bit unwieldy, that function. I'm not sure I completely like it, but this is just the first pass. There will be more passes on this in the future. Right, and now the very last thing we need to do with our birthdays is we're going to try and partner up all the single people. So I'm going to actually add a local variable, and it's going to be another list of citizens, and it's going to be a list of single adults. That's going to be of type CB citizen, object reference, and it's going to be an array. And what we can actually do is, if we go back to our first loop, if this comes back as false, we can actually just do another. Oh no, that's not right. We want to get the relationships. We want to get the relationship status. And if this equals single, we also actually want to do our age. We also actually want to get our age, and we want to make sure that this is greater than 20. And this is an arbitrary value. We're going to do an AND gate. So both these need to be true. And we'll branch off of this. Getting so messy again. Sorry about that. Single check. If this person's single and greater than 20, then list of single adults we're gonna add you into it. Let's do that, pull the array element in. Let's actually just pull this down and just plug these in like that, because there's too many strands coming off here. It's getting very, very messy. Okay, so now we should have a list of all the single people. So now we should need to go through them all. So let's do a for each loop, and we're going to do another reverse one. What I'm going to do here is actually the first thing I want to do is just check that these are still, if these people are still actually single, because that could change based on the the logic we run. So just a quick check in here to say, is this person still single, so we can still actually run the logic. If this, actually just before, plug that completed down into there. Right, so if this person is single, then I'm just going to do a straight up chance here. It's going to be a random integer. The max is going to be 100, and on everyone's birthday, if they are single, they have a less than 10. We're going to say you have a 10% chance every birthday that you are going to be on the hunt for love if you are currently single. So if this returns true, then you're gonna try and find someone. So we also need to do, so if we drag the target out here and we get our sexual orientation, we're going to need to do a switch on this. We can actually, this might actually be better done in a function, but I'll do the logic here first and then maybe we'll collapse it into a function. So basically what I need to do is need to get the list of single adults. And I'm just going to find, I'm not going to make this fancy, I'm just going to find the first available person to hook up with this person. Again, let's just do a quick check to make sure that this person is still actually single. I need to do a for each loop with a break there actually. Then that array can go in there. Okie dokie. Right, so gonna pull this node here so we can keep dragging our target out. So if this is true, then let's go into our switch statement. So this is where it might start to get quite messy because of the sexual orientation stuff here. We're going to have to do a lot of logic gates essentially. So let's start here. So let's start with hetero. Okay. The first thing we need to check is the sex of this person. That needs, if that is not equal to, so if we get the target sex out and the array element one, we just need to make sure these are not equal to each other. And we need to do an and logic here, and this target, they need to be, they basically need to not be homosexual. So we need to get the relationship, we need to get the sexual orientation, and that needs to be not equal to homosexual. So this is an AND boolean. Right, so let's bring this down here, and that will be hetero. Oh, I can't spell. Oh no, that's fine. So the sexes of the two people have to be opposite, and the person we're going for can't be homosexual if you want heterosexual to succeed. So that can be the branch. So if this is true, then we will continue on to do the logic we need to do. Okay, so let's do the homosexual one next. So for this one, actually I could probably drag these out because they'll be used in multiple. So these now need to be equal to each other. And the sexual orientation has to be, and the sexual orientation can't be hetero for this one to occur. So if we drag that down here, let's just neaten these up a little again. In fact, yeah, let's put all the actual logic we need up here, and then all the variables we need up there, and then we can put all the logic gates in the actual comments. Move that up there. Okay, so then that again needs to be an AND. Like that, and then this will be homo. That could be another branch. And then for bi, we just need to make sure that the other person is comfortable with us. So, so the two ands we've already got. We only need one of these to be true. So we can actually do an OR gate here. Just plug these two pre-existing conditions we've got in, and then that will be our branch. Okay, very, very confusing. I'm not gonna lie, I am confused right now, but I think we've got this right. Then we need to actually just say, hey, these people are shacking up. So if any of these return true, then I need to set relationship status to partnered for both targets. Set relationship status, set both of these. They're both partnered now. True, true, true. And then we also need to tell each other their partners. So let's drag this and we'll set partner. And the partner will be this person. Like that. And then for this person, we also need to set the partner the other way around. So set partner. That, and plug that into there. This has all gotten very complicated, I'm sure. It looks like a mess, but there is logic here, I swear. And then if this has succeeded, then we need to go back to this for each loop with a break and plug that into the break because we have found a partner now. So we need to just make sure that we're not continuing to run any logic. So let's just drag this all the way back. Like that. And then I think think that's us. So if I highlight all of these and I comment and say dating, that is going to be our dating loop. Compile and save that. Okay, right, I'm going to go back to our main game now. And what I'm going to do is, which way is the Y direction? Because it was the Y direction is this way. Okay, I'm going to line up all our people that I just kind of plonked in for testing, and I'm going to run and see if they actually generate new people, if some of them die or whatever. I've got the birthdays are on like every second at the moment, so hopefully we should see stuff happen. I'm going to create a lot of them because of the low chance of partnering up. I guess it might not work very well, but we will certainly see. We should at the very least see them die, but this will be a cool experiment to see if our stuff works as intended. Okay, so we've got a random bunch of people. I'm going to hit save and I'm going to press play. Okay, and then let's actually, I've put the simulation on the fastest speed, and let's see. Oh, we have children. We've got 2 kids there. I don't know why they spawned so small, but that's cool. We've got Pete. We've had a death. We've had a death there. We had another death. Okay, this is cool. We know it's working. We can see 2 kids have spawned up there. And we can see that people are dying off. So this is exactly what we wanted. We have citizens. We have people who are living and dying. This is really cool. We're starting to actually get some kind of ecosystem. I'm going to... Oh, there we go. So we've actually got a bunch of errors coming through. I think it's because... I think it's to do with this logic of them dying and us deleting the citizen and removing them from this list isn't quite working as I intended. Okay, so finding the actual problem. You need to do the remove index after you do the destroy actor, because of the way blueprints work, it goes backwards along all these stuff you've done. So what was happening was I was removing the actor from the list of all citizens, but then when I was calling destroy actor, I was doing that based on this logic here, which was running again. And it was basically getting the next actor along in the array and destroying that rather than the one we removed. So just swap those around and you should see it works properly. The other thing that I figured out was this spawn transform. We should just, we don't really need that actually. Let's just break that. We can delete this and delete this. We can just do a make transform, and it can just be, everything can just be set to 0 and the scale can just be 1. If you just do that, and then actually you can just delete this actor location one, make sure you re-plug into that, bring that over, and then just make sure to plug that as the location in, and then that should be all good. Just make sure, just make sure that that is the correct target. So you want that as this person. So you want that as the loop object. Just plug that into there. There you go. And then now, hopefully, when I run and they have their offspring, which does happen infrequently, I guess, but maybe one will pop up in a sec. Yep, you can see that they're actually full size now, and in line with their parent. Cool, so I think I'm going to call it there for the episode. Went long, very complicated. Any questions you have, please feel free to comment, because I confused myself at times in that one. Hopefully it did make some kind of sense, but yeah, I'm more than happy to help out if you comment below. Thank you very much for watching, and I'll see you in the next video. Bye for now.